Let's see what we have. A lot of this we've already talked about, so I'm just going to kind of skip it a little bit here. We have graphs of quadratic functions. I heard Jesse say back before it's ax squared plus bx plus c. That is the form. It's called a parabola, Gabe said. The parabola going through here. It has a minimum and a maximum. How do we tell if it's which one's which? Well, it reaches the highest points. How can we tell by equation if it's a max or a min? Minus, positive. Which one? The A term. The A term. If the A term is positive, it's going to be a minimum. If the A term is positive, if my A term right here is a positive, it's going to be a minimum. It's the lowest point. If my A term is negative, it's going to be a maximum. It's going to reach a maximum point on the graph. You can tell the difference between these two. This one has a maximum. This point on top is called a vertex. The vertex is the highest or lowest point of the graph. We'll talk about these in a second. And then you can see the axis of symmetry. The axis of symmetry, we draw it on the graph. It's not really part of the graph. What it's there for is to help form the graph. I want to see it on the graph. It is not a point, it's a line. Axis of symmetry, like this one goes through 3. I would write down this one to be x equals 3. It's always in the form of x equals. This axis of symmetry, you notice, goes through a -1. This one's x equals a -1. Only thing I don't see on this graph that Truman talked about a little bit ago, Truman said there has to be arrows on both ends of the graph. There should be arrows on both ends of the graph. Because parabola does not stop, it goes on forever.
So technically the domains of a parabola is always going to be all real numbers.
The domain of parabolas are always all real numbers. That doesn't change it. An easy way to think about it, let's go back to last chapter, easy way to think about it is, does it have any square roots? Does it have any denominators? No, so it's all real numbers. So, questions on that? So that's some stuff we talked about. Quadratic functions are any function in the form of ax squared plus bx plus c where a cannot be 0. If a was 0, this equation's gone. What kind of equation do we have? Linear. Linear. Therefore, that's why it says a cannot be 0. If it is 0, we don't have a quadratic. The graph of any quadratic function is called a parabola. Parabolas are like shaped like, I say U's. Parabolas are symmetric with respect to a line called the axis of symmetry. And we will graph some of these in a second as we go through. Graphing. Okay, there's two forms of graph. We have this form, the standard form of a quadratic equation. A times x minus h squared plus k. I want to think about this. H and k is my vertex of my graph. Now there's two forms. They call this the standard form. I call it a little different here. Standard form of a quadratic, I'm going to say is this. Y is equal to ax squared plus bx plus c. Vertex form of the equation is y is equal to a times x minus h squared plus k. One's standard form, the second is vertex form. You notice A on the second equation, A is the only variable that is, the only constant that's figured into it. H and K on the second one is my vertex. It's always what makes this 0 and the number on the outside. So my vertex is always H and K. On that one. On the standard form, my vertex is a -b over 2a. When I do a -b over 2a, that gives me the x coordinate of my vertex. How do I find my y coordinate?
X for the equation and get your y.
You plug in that value in to get the y, right? That will give me my y coordinate as I go. And there's a lot of ways of coming up with points. Now, as we go through here, let's see if I can get a graph here. Let's go with this one. F of x equals a -x plus 2 squared plus 4. Here's the equation. Let's talk about it first before we graph it. If I was doing this on a test, what I would like you to do is this. I want you to look at the equation and try to think to your mind and draw a picture on the side. First thing I want you to notice is where is the vertex at? -2 and 4. What makes it 0? And the number on the outside. Correct? Is this graph opening upwards or downwards? Down. My A is the value is negative. Okay? So off to the side so far, I didn't do anything. I just looked at my equation. I'm going to say, okay, here's my graph, -2 and +4, you said, right? I know my graph should look something like that, right? Now I'm going to graph it. See what I get. I like to graph with a table of values. What I usually do, and this is nothing different than last year, I have my x-coordinate, I have my y-coordinate. My first middle x-coordinate is going to be -2, +4, and that's going to be my vertex. There's some up here. -2 and 4. Now what I usually do from there is I go 2 units on both sides, even units. -1 and 0, -3 and -4. Does it matter which points I pick? No. But if they're even, you can use that axis of symmetry very nicely. What's that?
Well, by rights, could you just, like, if you just did plug on the other side, like, plug x-coordinate on the other side of the axis of symmetry, and you only graph one side of the quadratic, would that be wrong?
It would be, because I want to see the whole U shape.
Yeah, obviously.
But that's why I do a little bit of both. But when I say it doesn't matter what points I use, I mean, you could go 0 and 6 on this side and then 2 points on the other side. It doesn't matter. But if you do this way, it makes points easy to plug in. Like on here, I'm 2 units away here. Plugging in 0 into this equation is not hard to do, is it? 0 plus 2 squared. With the negative in front makes it? -4 plus 4. 0. So I know this point is 0. Now using the axis of symmetry, I'm 2 units on this side, I'm going to go 2 units on the other side, and that value is going to be also 0. Now I'm going with the -1. Let's go here. -1 plus 2 squared. 1. With a negative in front makes it a -1 plus 4. So I got a 3. I'm 1 unit on this side, go 1 unit on this side is 3. How many points do I have? 5 points, correct? Only to plug in 2. So now if I go on my graph, now I graph this out, -2 and 4, I'm going to put my vertex. I'm going to label my points here real quick, A, B, C, D, and E. So this is going to be point C. At 0, 0, A, -1, 3, B, -3, 3 is going to be C, and -4, 0 is going to be, actually I think I made one wrong here. This is going to be D, this is going to be E. So now if I do my graph here, my graph would look something like that. I also would include my axis of symmetry. I'm going to do that in a different color here. X equals -2. Correct?
What's the symbol for axis of symmetry?
What's the symbol?
AOS.
AOS. I would put AOS. If I was writing on my test and showing it, I would say AOS and then arrow, then x equals -2. AOS equals -2 is not right because it's an equation. Axis of symmetry is an equation. You want that x equal in there. You can't just say AOS equals -2. Question on that one. Does it look like my sketch I did? Yeah, I did a rough sketch just to know where I'm at, right? This is where I want you to think into the problem and say, okay, if I given you this problem and say, where is my graph going to look like? Where would it be? What's it going to look like? And then try to draw it. If you don't get the same graph, something went wrong. Draw this one up. Give me a second.
Did you include the -4 for that vertex?
Yep.
You
Yep.
include the negative?
Yep, it's what makes it 0 inside and a number on the outside, so it includes the negative on the outside. I get my points. A vertex is a 3 and -4. 2, -3, 4, -3, 1, 0. I use letters so that I don't mess up, make my graph real messy. I want my points labeled. I'll start with my vertex 3 and -4. 2, -3. 4, -3. 1, 0. 5, 0.
And if it comes to a V, it's incorrect as it is.
Yeah, it's a U-shaped graph, it's not a V. It's got a point on the bottom, it's a U. Axis of symmetry, down the middle. X equals 3. Always my x coordinate on my vertex. I should finish labeling my points here. A, B, and E. Good. That yellow's kind of bad, but getting the points in there. I'm hoping you remember this. I feel like we did this forever last year. So it should not be hard to graph these to start with. Okay. We did these last year too, didn't we? Just regular forms?
Yeah.
Now I'm going to give you an equation. Here's an equation for you. I'll make it bigger for some who have a hard time seeing. Okay. I don't want you to graph it first. I want you to find me the vertex first. You find me the vertex. I'm going to ask you a whole bunch of questions. Let's see what we have. You find the vertex. I'll give you a hand. Negative b over 2a will be the vertex. Don't graph it. When I say vertex, I don't just mean the x coordinate, the whole coordinate, right? And y. Okay, the vertex? Okay, now here's my question. Look at the equation. You look at your vertex in the picture. First question I ask you, some of it is going to be asked you to write down values. Write down my A, B, and C of this equation. What's my A, what's my B, what's my C? Second question. Is this graph opening upwards or downwards? Third equation. Third question.
It's a negative x squared.
Oh, did I miss a negative there?
Yeah, it's negative x squared.
How many use x squared? How many use
Oh,
negative?
it is a negative.
You just use x squared?
Yeah.
Let's go with x squared. Did you go with negative?
Yeah.
Okay, so you're how many went with negative? You know that I caught that. So. Okay, let's just go with the x squared for now, since everybody else went x squared. Your point is going to be pretty close. Your y coordinate is probably going to be off, but your x coordinate is probably just going to be opposite sides. You got a vertex at
Needs to be
1 point,
negative.
negative 1.5
Yeah. So I just change it.
to positive 1.5, right? What was my last question? Upwards or downwards?
Down.
Tell me what the maximum value or minimum value of this graph is. Tell me if it's a max or min, first of all. Write it down. Oh. And then tell me where it is and what it is. Where is the maximum happen and what is the maximum value? Tell me what the maximum is and where it happens. Well, let's get to the next question. Question number 5 is this graph going to touch the x-axis? That's
That's the fifth question.
a bit.
Well, this better be for some extra credit.
What? I think I was just thinking all the questions I can ask you here. What is the axis of symmetry? No, what is the equation for the axis of symmetry? It's 6.
I'm so confused.
What's 6?
6 is what is the equation?
Okay,
of
we're
the
still going with x squared, right?
Yeah, this x squared. This-
I'm so confused. So, can you, what was, 4 was the, if it's max and min, right?
3 was if it's a max or min.
Okay.
4 is what is the max or min and where it happens.
Okay.
5 is
What do you mean, like, where it's located? Like a quadrant, or what do you mean?
no, like what's the x coordinate, what's the y coordinate kind of thing. What was 5?
Axis.
Does it cross the x-axis? Does it cross the x-axis? 6 is what is the axis of symmetry? 7 is what's your y-intercept?
Wait, whoa, what was 6?
What's the axis of symmetry?
Okay, I got that one.
7 is what is your y-intercept?
6 is the x. No, it's the.
Axis of symmetry.
And 7 is what?
7 is the y-intercept. Now I'm going to make it a little harder here. Number 8, what is the domain? What is the
What
domain?
is that?
9, yes.
After y-intercept.
Y-intercept. Number 8 is domain. Number 9 is range. Anything else?
I couldn't get an x squared every time she had x. Can't remember.
Okay, well now let's start. How many questions is that? 9 questions, right?
Yeah.
Easily put, I mean, if I put 2 points a question, there's 18-point question.
Do you?
And we didn't even really do any math. We just called a point and then we go look at the graph, right?
Yeah.
Now if I graph, it's more, right?
Yeah.
Doesn't take much to come up with a lot of questions. So what's the answer? Number 1,
1.
My- A was 1, B is a -3, and C is 7. Correct? Number 2, this graph is going to open upwards. How do I know? A is positive, right? Number 3, this will have a minimal. Opens upward, it has a minimal. Correct? Number 4, It has a minimum value of, now let me think here for a second, we're using one, let's see. It has a minimum value of 9.25 at x equals 1.5. That sound about right?
How do you write that, or what?
Isn't it
how do you
1.5 and
figure it out?
4.75?
I'm just thinking here, if I plug in, maybe I did it wrong. No, you're right,
How do you figure
my
it
fault,
out?
I missed a negative. Negative 2.25 and 4.75?
Yeah.
Okay, it has a minimum value of 4.75 at x equals 1.5.
I have a question. When you get to the negative b over 2a,
Yep.
and then you get
Oh,
so you get like a negative 3 over
I
2.
don't know.
Then what do you do from there?
When you do it, negative b over 2a on this equation right here.
Yeah, you get a negative 3 over 2.
Okay, this is how I got my vertex, or my maximum end. B is a negative 3, right?
Yeah.
Two negatives make a positive, so I get 3 over 2. 1.5. Then I went back up here and got 1.5 squared.
Oh, so you plug it back.
1.5 plus 7, so I got 2.25 minus 4.5 plus 7, and then I should get 4.75. This is what my value is, max or min is. This is where it happens.
Oh, so if you just wrote it, it happens at the vertex, and you give the point of the vertex, does
So
that count?
is that your x and your y?
Yeah, that's my x and y. I would rather see it as my maximum value of, or minimum value of, this one would be minimum value of 4.75 at x equals 1.5.
Okay.
And the reason I say that is because if I just say at the vertex and I ask somebody, okay, which one's my maximum value? I don't know. They don't know which one represents which. This, I want you to understand that this is my value. This is where it happens. Okay? That was question number 4.
Yeah.
Question number 5 was, does it touch the x-axis? I'm going to say yes.
No.
I'm going to say no. Okay? Where's my vertex at? 1.5 and right there's my vertex. Which way is it opening? Up. Is it going to touch the x-axis?
No.
Not going to touch the x-axis.
How do you figure out where it touches the y though?
Okay, now we'll get there. What's the next question? Well, axis of symmetry is x equals 3 halves or 1 half. Y-intercept, where does it cross the y-axis? 7. Plug in 0 for x. That's your y-intercept. Plug in 0 for x. Plug in 0, that'll give you the y-intercept.
So can you find the x and y intercept?
So the x-intercept is just your x.
The x-intercept would be hard. That's hard to form.
Yeah, this is.
The y-intercept is very easy. You just plug in 0 for x. Okay?
So we just did.
So the y-intercept is at 0, 7. 0, 7 is the y-intercept. So plugging in 0 for your x values will give you your y-intercept. Domain.
All real numbers.
I hope you were listening earlier. It said the domain of all quadratic functions is all real numbers. Range.
I believe.
No,
The range.
4.75.
So we can just
Okay,
write down
profit.
all real numbers.
4.75.
No, it's
4.75 to infinity, you're saying the range is including 4.75 or not?
actually bracketed.
Yep, was that?
Included.
Including. So the domain on here, I would write down as negative infinity to infinity. And my range would be 4.75 to infinity. Why is it 4.75 to infinity?
That's the lowest one.
That's my lowest minimum value, right? Minimum value, and it goes up from there. So that's my range. Find these values. Like again, this should be reviewed.
I got a question. You know the vertex?
Yep.
Right. That's the equation. Is there what's telling us that what's inside that the space of the U?
No, because we had a shade in.
See
What does that tell us? Like
inside of it?
yeah, inside of the vertex. I mean inside of the
Graph.
yeah, inside of the graph.
What is it telling you? Not really a whole lot. I mean, it just tells you the values that are greater than that or less than that, inside and outside. Depends on what you have.
Will range always be the minimum to infinity or the maximum? Yeah.
Maximum to the negative infinity, or negative infinity to the maximum, if you're going downward.
Okay.
Now there is other things to this parabola that we haven't talked about that we will add on. For example, I want you to start with this. A parabola is based on what we just did, points and all this kind of stuff. A graph is formed with a lot of other things dealing with a parabola. And hang on here, I'm just going to throw a new sheet out here. Let's say I draw this parabola here, and we will get into this. And this is what I mean by, I want you to do your homework, I want you to understand it, and I want you to practice and remember what we did before, okay? Because we add on, every time we take something like this, we can add stuff onto it. For example, what did we just talk about on the last problem? We talked about the axis of symmetry, right?
Yeah.
We talked about the vertex. We talked about the points, correct? But really, what other things we have with the, what we will get into, it might be a little while before we get into it, we have other points of a parabola. One point inside here is called the foci. Another point outside here, and this is very interesting, it's called the directrix.
Oh, yeah.
Okay? We're going to add these concepts to it. You know, and what happens here, and my graph is a little off here, so I'm just going to reshape my graph here for a second. What's going to happen here is something like this. The distance to a point, and mine's off a little bit, to the directrix is always the same. That's how a parabola is formed. So in other words, the distance, if I take my directrix line here and drew a straight line up to the parabola, and then I took from that point straight to the foci, it's the same distance. Mine's off, I know that. But this distance and this distance should be the same if you're drawing a parabola.
Is that how you can get the second parabola?
How do you find the direct
on the other?
We will talk about that. That's what I mean by understanding what we do now. I know a lot of people, what happened in these first 3 chapters is this, and a lot of people are bored in these first 3 chapters and say, well, we did all this last year. I don't need to do homework. You might not remember everything. I want you to review what we do know so we can add stuff on it as we go. This is, by far, the last chapter that you have to review. After this, it's all new stuff. So this is where I need you to make sure you understand everything going up to this point. And that's just a part of it. Some of the stuff we get into is really neat names to it. Truman, do you remember the name of this thing?
Oh,
It's a stupid name, actually.
I just remember the full guide.
Okay. There's a line that goes through the foci that's equal distance from there to the directrix and everything.
Should
I think
form a
most-
square.
What?
Should form a perfect square.
Kind of like a perfect square almost. It's called the lattice rectum.
Oh,
Think about that name. The lattice rectum. Whoever thought of that had no time on their hand. But lattice rectum. Why I know that, I don't know.
Doesn't sound like that on a cell too.
So I mean, thinking about this going through here.
Yeah, the last is having
Again, this is, I'll be honest with you, if I went right now and I asked you, and I know, if I asked you to say, turn in your homework from this year, all the problems I assigned, okay, 100% done. Let's go down, let's make it nice, somebody say 50% done.
Of all of the homework.
All the homework.
like not just one
Maybe
dimension.
around
I'm at least maybe at 5%.
You know, 50% done.
45.
10%?
Oh, yeah.
That's what I'm for having. I haven't been signing a lot. You know, I've been going by 3s and 4s. But we're getting 50%. You know, I start handing in homework for grades. You know, what happened to that? I'll keep handing in homework, but some of your grades dropped 20% since we handed homework. Because they're not doing even that. You know? So, I mean, that's the problem we had to do. So, when I say look at this over, I know you guys, when you look at this stuff and you're saying to yourself, we did this so much last year that, I mean, I look at minimum, maximum, and applications of it. It's all the same stuff we did. Okay? Let's say I give you this problem. Could you do it?
No.
You know, if I spent a couple days
If
on
you're
it,
coming back, I could. If I think of what I can do.
Okay, you got 64 yards of fencing to enclose the figure that's below. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? Could you do it?
Yeah.
We run into a problem here now. Okay, we just did all this stuff. We know how to find a vertex. I know how to graph because we did a lot of that. Now applying it. Do you remember all that?
No.
And that's where I say you need to do some homework. I don't care if you do all the graphing ones, if you know how to do some of them. But again, what's going to happen is it's like anything. Plugging in values in yesterday's test. The hardest question on the whole test was f of 4. F of -4. That was the easiest question, I should say. Right? 40, 50% of you got it wrong. Easiest question on the test, most of you put in 4 instead of -4. You put a -4 in the first part, you put 4 in the second number. So I mean, that's the thing. Practice is going to make it better. So make sure, and I don't know, this is my spiel for the day. I know I can keep going through quadratics and we'll practice some word problems tomorrow, but make sure you do some homework.
what's the homework?
The homework I have down for the day.
Very well.
1 through 120 by 1s. 3 through 72 by 3s. 309.
What is it?
309. 3 through 72 by 3s. 24, 48, 72.
44,
24,
24,
48, and 72.
8, 6, 7, 5.
What are the kids like?
309.
Work
What's this work?
for Edmodo.
I already got yours sent back to you on your cell phone.
Okay.
I corrected. I looked at your work, so you can keep it and look at it. So there's some fixing I expect you to do,
Okay,
so you
yeah.
can look at the work there. And see
Alright,
it.
I wasn't sure if you could see it.
I saw the first one was better than the second one.
January 17th. Because it was like 7 weeks and normally it's only like 6. So I'm like, I'm not going to make it any farther. It's 7 weeks. So I go back up.
Where are they?
17 and 45. So you should see how that 10 to 10. I go let you start people next Thursday. You go next Thursday. I know.
Right? Like a diamond.
Can you see your class?
That's because it was 32 minus 10.
Oh, I couldn't read it. That's why. Blind in the back.
What's that down?
Sorry. Ouch. I didn't know what I was doing.